All right, so welcome back. This week we're gonna talk about something called factoring. Polynomials you've probably talked about earlier in grade 9 level math. You've worked with monomials, binomials, trinomials, but in grade 10 we're gonna introduce something called factoring. So factoring, kind of the new concept. It's going to be used a lot in quadratics, so quadratic functions, determining x's in quadratic equations, and yeah, it's used a lot in higher level math, so this lesson is quite important. So today we're going to be covering expanding and factoring polynomials, the greatest common factor, and something called grouping polynomials. Before we start, I want to kind of go through some vocabulary, like some of it may be familiar to you, but we're going to first talk about degree. A degree is basically a variable's exponent. So over here, there's kind of like a chart talking about the degree of a polynomial or a degree of a term. So polynomials, if you remember from grade 9 math, polynomials were terms, so different terms that were put together. So terms are basically just positive or negative values. It can include variables as well, but it can just be a normal number like 36, as you can see at the bottom. Oh, someone else has entered. Hello. So we're going over the vocabulary right now. We've just went over degree. So a degree is sometimes called an order, and the degree is basically a variable's exponent. Now, if you don't remember what a variable is is just any unknown value, and we usually assign a letter to it. Here, I'm gonna give this variable the name x, and it's x squared. So in this case, this x has a degree of 2, which means that little floating 2 is the degree. Now, in an example like this, what would the degree of y be? In this case, the degree of y is 3. It's pretty self-explanatory. Later on, you'll kind of get to know degree of polynomials. So in the degree of polynomials, so when you have a bunch of terms together, the degree is just the highest degree of a term. So over here, this polynomial is made of 3 terms, right? One term has a degree of 5, one term has a degree of 10. Remember, you add up the 6, the 3, and the 1 above said. So there's actually a little 1. It's not usually shown because it's kind of redundant. And the last term has a degree of 11. So 5 plus 2 plus 4, 11. So what we do is we actually use the degree of the biggest degree of any term, and we call that the degree of the entire polynomial. Anyways, okay, so you've heard me talk about the word term a lot. So a term is basically a single number, or sometimes a variable, that are multiple, or you can even have like variables multiplied together, which is kind of confusing, but it will make sense soon. So a term is separated by addition or subtraction signs. So basically, you can think of any number by itself as a term. Over here, we have 2 terms, right? 3 and 4. I'm going to add another term, x, and even have variables multiplied but with other variables. So let's pick something really wacky, like y cubed and z to the 4th. This whole thing is 1 term, not 2, but 1. Because, you know, just the key thing to remember is that terms are separated by plus or minus signs. All right. And the degree of the polynomial I've kind of talked about a tiny bit earlier. So it's basically the highest degree out of all the terms with non-zero coefficients. What it means when it says non-zero coefficients is just the coefficient, which is the number that's beside so over here in this number, the coefficient would be 57. So the coefficient can't be 0. Because you know, if a coefficient was 0, then the entire term would be 0, which is pretty pointless. So that's why we say non-zero coefficients. The degree of a polynomial must also be a non-negative integer. So you can't have a polynomial with a degree like -3 or something. Let's move on. Some more vocabulary. This is kind of a refresher from grade 9. In grade 9, you've learned about monomials. Oh, there's a question in the chat. Oh, hello. Yes. Sorry, only saw that now. So monomial, binomial, trinomial, polynomial, they're basically, so if you look at the prefix of the word, so mono starts with M-O-N-O, and mono usually refers to one. So what this usually means, or what this means, is that it has one term, monomial. And binomial, you can think of a bicycle. Bi is the prefix for things that have two terms. Like a bicycle has two wheels. A binomial has two terms, so bi prefix. So I should highlight it. It's more obvious when I highlight it. That was a bad highlight. And then we have trinomial, which is, you guessed it, 3 terms. Think of a tricycle. A tricycle has 3 wheels. And poly, just a Greek word meaning many. So I'm going to write this down, many. So this just refers to 4 or more. Oh, that was bad handwriting. 4 plus terms. Over here in this chart, it says only 4, but we will remember it as 4 plus because, you know, you can have polynomials with 100 terms, 1,000 terms. I don't know why you would have a polynomial with that many terms, but you can. It's possible. And then we're going to talk about something called expanding and factoring. So these are operations that you do to polynomials, kind of like how you can add numbers together. Adding addition is an operation, and so is expanding and factoring. Now these operations are opposites of each other. So let's bring up the example of addition again. So if you want to undo addition, what do you do? Well, you'll usually use subtraction, right? Actually, not usually, you have to. So addition and subtraction are opposite operations, and expanding and factoring are also opposite operations. And we're going to kind of talk about how they work. So over here, oh, right, expansion. Expansion, you've probably done a lot in elementary, where you were given a huge number, like let's say 123 or something, and then you would write it out in expanded form, which basically meant you had to like split it up into like 100, and then like 2 10s, 3 1s, or something like that, right? So expanding in grade 10 is kind of like that, but more complicated, obviously. Everything has to be more complicated. And factoring is just the opposite of that. So putting it all together. So let's take a look. Over here, I have some examples to try for expanding. So let's try some examples first. Over here, I want to first multiply a monomial is one term, by a polynomial. This is not exactly right because this number isn't a polynomial. It's actually a binomial, so I guess I have to fix this typo. This is a binomial, yes, okay. So what you normally do is you want to multiply these expressions together so you get one big expanded form of, so there are no brackets. You want to get rid of the brackets. So what you would usually do is you would have to multiply the 2 into brackets. This is called the distributive property. I'm just going to write it down at the top. Just when you distribute a number outside brackets, inside the brackets. Distributive property. This is kind of like an aside. Over here, what we're doing is we're distributing 2x, this term, 2x, inside the brackets. So what we're basically doing is 2x, first it's multiplied by x, right? Oh, I shouldn't put times or else you might get confused with, I want to use a dot instead. Just to kind of remember, a dot also means multiplication. It's kind of like a way of differentiating because we use x's in mathematics a lot. So a lot of times people will get confused between, oh, what's a multiplication sign? What's an x? Like, what's a variable? So I guess for the sake of this lesson, I'll just use a dot to symbolize multiplication. So what we're doing is we're going to multiply 2x times x. I'm going to put these in brackets just so you can kind of see it better. And we're also going to have 2x times positive 5. So plus 2x times positive 5. Now we're going to simplify. So 2x times x is equal to 2x squared. If you remember your exponents laws, these x's both have a 1 on top, like an imaginary or an invisible 1 that we usually don't write because it's redundant. So we just add these two or multiply these two together, which means we add the powers and we get 2 times x squared. Then we add our second term, which is 2x times 5. So in this case, what you do is 2 times 5. So imagine 2 x's as kind of a group. Like you have 5 of those 2x groups. So let me kind of draw out a visual for you. We have 1, 2, 3, 4, and 5. Now if I draw it out here, so I have 5 of these 2x groups, right? So how many x's do I have in total? So let's count. 2, it's over here. 2, 4, 6, 8, 10. So we have 10 x's in total, which gives us our final value of 2x squared plus 10x. I tend to circle or put my answers in a box because it just makes the work look a bit neater. Teachers really like this too because it makes their marking, makes their job a lot easier. So over here you can kind of see, kind of blurb the FOIL method. We're going to use that in the next question. So over here we want to multiply a binomial by a binomial. What that means is this term, this first term, is a binomial, which means it's consisted of 2 terms. We want to multiply these 2 terms with these 2 terms. Now most people, what they're tempted to do is they'll just multiply x times x, and then 1 times 3, and then bam, that's the final answer, right? X squared plus 3. Well, unfortunately, it's not that easy because the 1 still has to multiply the x, and the 3 still has to multiply this x. So what we use is something called FOIL. Now FOIL is actually an acronym. FOIL stands for, I'm going to write it at the top. I'll use green, why not? FOIL stands for first. Oh, you can't see it very well. Never mind, I guess I won't use green. What's a good color? Maybe white? I hope white will show up well. F stands for first. And then O stands for outside. You'll see what I mean in a minute. Then I, oh no, I'm running out of room. Maybe I should have written this at the bottom. Haha. Alright, I'm gonna clear up a bit of space. Alright. F first. O outside. I inside. L last. Okay, so what these numbers mean, or what these words mean, basically what it's telling you a kind of like a pattern for multiplying the binomials. Because, well, like I said earlier, a lot of students will just multiply like the x times x and the 1 times 3, and then their answer will be wrong because they haven't multiplied everything by everything else yet. So we're basically using the distributive property in a binomial, which is a bit more complicated, but we can use this FOIL to help us remember. So I'm going to just give you an example because explaining sometimes is a bit hard to understand. So what first means is that you're essentially multiplying, you're going to multiply the first of each binomial together. So first, x times x. I'm going to put this in brackets to make it easier to differentiate. And then outside, you're going to then multiply the outside values, which in this case is x and 3. So FOIL is just an organizational strategy, so you can remember to multiply everything by everything else. X times 3, and then I is inside. So what this means are the inside the inside values. So 1 and x, which is just x, but I'm still going to write it down. That was a really bad one. And then last are it's just referring to the last values, which is 1 and 3. 1 times 3. So now we can't leave our answer like this because it's not simplified yet. We want to make it nice and neat to read, like the one at the top. So what we're going to do is we're going to multiply each of them. I'm going to do all the operations inside brackets first. Remember BEDMAS, brackets, was it exponents? Yeah, exponents, division, multiplication. So brackets always comes first. So we're going to do all of the stuff inside the brackets, which is x times x, x squared, x times 3, so basically 3 x's. 3x. Oh my gosh, I forgot to put plus signs between all of these values. Oh no, it's becoming messier. So I was actually supposed to put plus signs between each term, but I didn't. Oops. So let's just move on. I'll have to fix these notes. 1x is just the same as x. And then lastly, 1 times 3 is 3. So you might be tempted to think this is the final answer then, right? Well, you're almost done, but there's one more step to do. Because if you remember from grade 9, my teacher hammered this into me, but we always have to remember to combine like values. Combine like values. Exclamation mark. What this means is that 3x can have an x added to it, which will give it 4x. Now, you might be wondering, why can't x squared have 3 added to it? Well, x squared and x are different. It's kind of like, imagine having a completely different variable. That's what this is essentially. X squared is not the same number as x is, so you can't combine them. But x is the same number as this x, so you can combine in this case. So this is our final answer. X squared plus 4x plus 3. Oh no. I'm gonna have to write this down on my goals. Become neater. I always scribble all over the board. Yeah, hopefully you can read this. If not, I'll rewrite all of these notes out later after class and upload it. But this one is a bit different, so let me just clear out the board. Oh no, I accidentally cleared the top. Oh well. Okay. So for our next example, we have kind of the same thing, except this one This first value in the first binomial has a coefficient, or I shouldn't say value, I should start using technical words. So the first term in the binomial has a coefficient of 2. So the ones before, the one that we were looking at before didn't have any coefficients, it was just x, right? But you shouldn't let this bother you because you do it the same way. So we're gonna use the method of FOIL first, which means the first terms in each binomial. 2x times x plus the outside terms, which is 2x and 4, 2x times 4, and the inside terms, 3 times x, and the last terms, which is just 3 times 4. Now we're gonna do all the operations inside the brackets. 2x times x is equal to 2x squared plus 2x times 4, which is equal to 8x, because 2 times 4 is 8. And then you still have the x. Plus 3 times x, which is just 3x. And 3 times 4, which is 7. Now, we're not done yet because we notice here how these have like terms. These are like terms, so you can combine them, which will give you 2x squared plus 8 plus 3 is 11x plus 7. And this is our final answer. Once you do lots of factoring, your teachers will give you so many worksheets, you'll get sick of it, but you'll be doing factoring for the rest of high school. For the rest of high school, yeah. Very important concept. Sometimes there is no easy way around it. You'll just have to practice. So over here, we have a binomial times binomial, kind of like the ones at the top, except we notice here that one of our terms is negative. So how does this negative value affect our final answer? Does anyone have any guesses? Well, it's a bit hard to kind of guess at first glance because this is still new. So let's just go through it. Once again, FOIL first terms, x times x. Did I make my pen thicker? No. Times the outside terms, x times 5, times the inside terms, x times negative 5, don't forget the negative, times the last terms, which is negative 25. So over here, you notice how there's a plus negative. It's kind of redundant. So what you can do is you can actually simplify this to just be negative. So minus 25. Oops. Minus 25. Okay. Now we're going to do all the operations inside again. X times x is x squared plus x times 5, 5x plus x times negative 5, negative 5x. Now over here we have the same thing. You have a plus negative, so adding a negative value, which can be just simplified to subtracting. So I'm just gonna put a minus sign here instead. Minus 25. Now what do we have here? When we combine these negative, or these like terms, this negative 5 and this positive 5, we actually get 0. And I ran out of space. Let's move it here a bit. So what we end up is, so these values actually cancel each other out, so we can disregard them. This leaves us with x squared minus 25. So in this case, we actually got a binomial as our answer. Because earlier we were getting trinomials, but when you have a negative, actually we'll talk about this very soon. So let's save it for later. Ooh, something to look forward to. Okay. So over here, I'm kind of just going over the distributive law, where you have a times the binomial b plus c. So what you do is you would multiply a with b first, and then multiply A with C, which is exactly what they show here. Okay, now we're going to go on to factoring polynomials. So this is the opposite of expanding. Kind of like how subtraction is the opposite of addition. We'll bring it back to its original value. So when you factor polynomials, you want to write the polynomial, or you want to write the expression, which is what we call a polynomial, as a product of polynomials. So product just means that you want it to be like two polynomials multiplying each other, which is kind of what you were seeing earlier here. So this was actually a factored factored expression, sorry, not term. You have one polynomial multiplying by another polynomial. So this is in the factored form. This is what we call factored form. And this is what we call expanded form. Anyways, so factoring polynomials. There are three major types of factoring. I'm going to highlight three major types of factoring. One is factoring by removing a common factor. So a common factor is a number, or I shouldn't say number, a factor, but I also shouldn't define it with the word. So remember when you were in the last lesson, actually I think this was 2 lessons ago, when you were taking out GCFs, LCMs, multiples, factors, all of that of numbers. So what you can do here is you can remove the factor that both of these numbers have in common. So let's break it down. What are the factors of 2x squared? Well, there's x squared, which is really just x times x. So we already took out 2 factors, and there's 2. Can 2 be factored any further? No, because it is a prime number. So over here we have the three factors of 2x squared, which is 2x and x. Next, we're going to take a look at 10x. So what are the factors of 10x? Well, there's x, so you can take that out. And there's also 10, but 10 can be factored because it is an even number, first of all, so you can take out the 2, which will leave you with 5. And can 5 be factored any further? Well, no. So these are the factors of 10x. Now, between these two numbers, are there any values that are the same? That was kind of a, yes, okay. So if we look here, we can see over up here, 2x squared has 2 times x, and 10x has 2 times 5 times x. Now we can see that the number x repeats twice, so we can take that out. This is a common factor. And there's also another one, which is 2. It's in both of them. This is also a common factor. So what we can do here, we found the 2 common factors, so let's bring it out of this expression. So let's take it out. Let's take it out. It's kind of like you're plucking the factors, the common factors, out of the expression. Now, if you take these numbers out, so if you take 2, oh, I shouldn't be writing in white. Oh well. So you took out these 2 factors out, right? You're left with, what is left? On the top, once you take out these 2, you'll be left with, let me grab another color. You'll be left with x, and from 10x, you'll be left with 5. So what this means is you just bring these orange values, x and 5. So these are the leftover values. So now we've successfully taken out the common factor from these 2 numbers. Well, actually, we've taken out 2 common factors, but what we can actually do with these is, you guessed it, we can simplify it. So this actually just becomes 2x. So the final answer is 2x times x plus 5. We've taken out the 2x, which was the common factor in both of them, out of the expression. I know it seems like there are lots of steps and you might not remember, but don't worry. Practice makes perfect. So, unfortunately, factoring a trinomial is a bit more complicated. Wonder if we're gonna be, yeah. So factoring a trinomial is a bit more complicated than that. Now I can't do it here because it'll take up a lot of space. So I'm gonna try moving this to a new slide so we can have more space to work with. Let's see, insert, new slide. Yeah, I'm gonna paste these down. Okay. Let's use white since white shows up better. So over here we have x squared plus 4x plus 3. So when we're factoring trinomials, it's a bit more complicated. There's actually a trick to helping you factor it faster. So if you look at these two terms, how you do it is that you know that there are going to be two binomials, right? That make up this trinomial, because earlier in all the examples earlier, this was how it worked. We got two binomials and then multiplied together, they made a trinomial. So what we're going to do here is we're going to do it the opposite way. Now it's a bit tricky because we actually have to do it by trial and error to figure out which values actually work. So what we're gonna do, okay, so we have x squared over here. We know that x will have to multiply into it somehow, so let's just put it down here. Now we know the first term, but we just need to figure out the second term in each of these binomials. So how we figure it out is we actually, it's kind of not really intuitive, but trust me for now. We have to find a number that will multiply to give you positive 3, multiply, and it will add to give you positive 4. Are there any numbers that will multiply to give you 3 and add together to give you 4? Now, an easy way to look at this is to just do some factoring. You can figure out the factors of 3 and then try each of them together to see if any of them will add to get 4. Now, this number is pretty easy because 3 only has one factor really, or two factors, 1 and 3. Now, do these numbers add together to get 4, to give you 4? Well, yes, they do. 1 plus 3 is equal to 4. Cha-ching! We have found our values. So what we do is we just put the numbers in, oops, sorry, not 4, 3. And it's as simple as that. It may not make a lot of sense right now, but you'll kind of see patterns as you move on. So just remember, look for two values that will add to give you this middle term and multiply to give you this last term. The last term, by the way, is sometimes called a constant, or all right. So this one is a bit trickier because now we don't know. I want to move this down a bit because, oh, I should also probably use a different color. So now we don't know if the first term is an x or not. Actually, we do know that one of them will have to be an x, but we don't know what the other term will be. So let's just leave them both blank for now. I'm gonna add this plus sign to separate it. So we have to figure out these two terms. So when figuring out when the leading coefficient, so the coefficient that's kind of in front of the biggest degree, the variable with the highest degree, I guess I should say. What you have to do is you actually have to multiply this by the last term. It's a lot of steps. So you have to multiply it by the last term. 2 times 12 is 24. And then you have to find factors that multiply to give you 24 and add to give you 11. Multiply and add to give you 11. Oh, so many arrows everywhere. I'm so sorry. I will clean this up, I promise. Are there any numbers that do that? Well, let's try. So we can factor out 20, find what are some multiples? No, not multiples. Sorry. What are two numbers that will multiply to 24? 124. But do they add to give you 11? No, they add to give you 25. So that doesn't work. Cross it out. 2 and 12. Do they add to give you 11? Well, 2 plus 12 is 14. So that doesn't work either. 3 and 8, maybe? So 3 plus 8 is indeed 11. So this works, which means we can input these values inside here. Aha, sorry, I jumped the boat. No, we can't. We still have to figure out the first term. This is where I'm going to introduce you to a concept called grouping, which we're going to kind of talk about a bit later. Oh my gosh. There's still so much to go through and we're almost out of time. Oh no. Okay, so grouping. Let me just make a note. We'll need grouping and then we'll come back to it after we've talked about grouping. Okay, so let's move on to the next slide. Greatest common factor. This is kind of like a review from a few lessons ago. So greatest common factor is just when you want to find the factor, the biggest factor that's common to both 48 and 72. So we can start by factoring both of these numbers out. 48, let's first take out the 2 because we know this is an even number. So you can always take out a 2 from even numbers, except when the number is 2, of course. In which case you'll get a 2 and a 1. So we have 2 times 24, but 24 is also even, which means we can take out another 2. We get 12, and 12 is once again even, so we can take out yet another 2. 6, oh, look here, another 2. Till we get 3. Can 3 be factored any further? No, that means we have finished factoring. Let's rewrite this in a neater way. 48 is equal to 2 times 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. More like 2 to the power 4 times 3. Huh. Made it so much neater just with that tiny number at the top. Next we have 72. Let's use a different color. I'm going to use orange for 72. It's an even number, so what can we take out? A 2. Then this leaves us with, what is this, 36? 36. Oh my gosh, this is a bad 6. 36 is also even, so we can take out another 2, which will give us, what is this, 36 divided by 2? 18. And we can take out another 2, which gives us 9. Now is 9 the end of this? Is 9 the final factor? Or not the final factor, a prime number. Is 9 a prime number? It might look like it because it's odd, but it's not. 9 can be factored into 3 times 3. And my computer is running low on battery. I will need to grab a charger. Let's finish this question and then I'll let you do the second one, which is kind of the same idea, but a tad harder. Over here, we have the factors white. So what are the common factors in these two numbers? 72, we have 2, what is this, 2 cubed times 3 squared. So clearly, we do have a common factor in the 2's. There are 3 2's that are common. And we also have a 3 that is common. So let's multiply this out. 2 times 2 times 2 is 8 times 3 is 24. All right, so this is our greatest common factor, and we're gonna have to finish GCF 2, 24. Now let's look at the second question. I'm going to clear out the board a bit. Don't worry if you can't really grasp the concept of GCF right now. It does take a lot of practice to get used to, but there are a few worksheets on the folder that you can kind of go through. So over here, we want to take a look at 6a cubed. Now let's first factor out 6a cubed. Well, we do know automatically that a multiply by itself 3 times. So we've got that taken care of. And 6 can be broken down into 2 times 3. That was quick. So the GCF of 6a cubed is equal to 2 times 3 times a times a times a. I could have just also written a cubed, but I wanted to kind of help you see it better. Next we have 9a squared times b. So what we can do here, because these are all multiplying each other, so this is technically what it's saying is it's just 9 times a times b, right? The b can come out of the a's, but we have 9. So can 9 be factored further? Yes, it can. 9 is just 3 times 3. So essentially, 9a squared b is just 3 times 3 times a times b. Yeah, this was just another method of kind of factoring. Most of these numbers, these terms are easy enough that you can kind of tell just by looking what the factors are. I kind of wasted time by going over all of them. But over here, let's look for the common factors. So we do have a common factor here, which is 3, not 13. This dot is supposed to be the multiplication symbol. We also have an a and another a. Wow, that's a bad square. Another a, there we go. So we can bring these down. The other values are not common, so we'll leave them alone. So the GCF is 3 times a, aka, haha, see what I did there? 3a squared. All right, so that was just a bit of a GCF review. And over here, how we're factoring a polynomial by removing the GCF, which is kind of what we did earlier. I kind of jumped the boat there, jumped the gun, jumped the boat. Yeah. Removing the GCF. So factoring is when a sum or difference of terms is expressed as a product of factors. So 8x squared, y squared, all of that can be factored by a process called removing, which is also more technically known as dividing out, because that's literally what you're doing. You're dividing that term or that common factor out. So, at the bottom, I've given a little example. So 4xy cubed, or squared, sorry, times 2x plus 5y can be expanded to give 8x squared y squared plus 20x y cubed. So what's been done here was just basically the 4x y squared has been distributed into each of the terms in this binomial to give this. Now over here, the opposite can be done. So if we want to reverse this operation, we can factor 8x squared y squared. So we can take out the common factor, which is, well, over here it kind of asks what is the greatest common factor. Well, here's a major hint for you. The greatest common factor, you can do it the hard way, or most people are able to kind of just look at the term and be able to kind of see the common factors. So for example, you can see there's a y squared and a y cubed. So obviously the y cubed isn't in both of them, but a y squared is. So you can take out a y squared. Next, you can also take out the x. And then this one's a bit harder, 8 and 20. So what common factors do 8 and 20 have? Well, there's obviously 2 since they're both even. But when you divide these numbers both by 2, you actually find another even number, which means they can actually be divided by 2 again. So you can divide them again. This will give you 2, and this will give you 5. Now they are not common anymore. So we've divided by 2 twice, which means we've technically divided it by 4. So this leaves us with 4xy squared. Please let me know if you don't really understand or if you have any questions. I'm sure the people watching the video would benefit from any questions, so go ahead and ask them. If not, I will move on. So this was just removing the GCF of a polynomial. Now, here's something that students will kind of struggle to kind of comprehend. So the greatest common factor doesn't always have to be one term. They can be binomials. So in this case, in this example, there's actually a greatest common factor between these two. So these two terms. That greatest common factor is x plus 7. So we can actually take these out. Let's take it out. And what's left is 4x minus 3. 4x minus 3. And ta-da, we just did a factorization without going through all the trouble of finding, oh, what's two numbers that multiply to get this or add to get this. We were able to factor this just by finding the greatest common factor. So you can definitely save yourself a lot of time by just looking for these patterns, or not patterns, these factors. Over here we have the same thing. We have 2 terms. Oops. We have 2 terms. And then, or not 2 terms, gosh, 2 expressions, 2 terms, yes, 2 terms, sorry. But they both have a single common factor, or not a single, but a binomial common factor. So we can take that out, 2 minus 2y, and what's left is 7 plus 2y. And once again, we've done a factorization without going through all the trouble of finding 2 numbers. Same thing over here, although these numbers are a bit bigger. So what you have here, you have this is actually 1 term, but you might be thinking, if I take out this 4a plus 1, won't there be nothing left? Well, actually, you can think of this number as having this term as having a coefficient of 1 in front of it. Every number does have a coefficient of 1. We just never write it, because if we did, well, it would just be a pain because we would have to write that 1 in front of everything. So, anyways, back to the topic. We can take out this common factor, 4a plus 1, and what's remaining is 9a plus this coefficient, plus 1. Yay. And we've just factored it. All right. There are also lots of questions in there that you can take a look at. Oh no, we're really low on time. 2 more slides so we can do this. Okay, so the last thing that we're going to go through is factoring by grouping. What that means is basically, why is there a random negative 6x here? I have no idea. I will take that out later. But there's not supposed to be. So just ignore that negative 6x. I'm not sure why it's there. I'll pass it out. What you are doing when, maybe I should just delete it since I can edit. Yes, okay, perfect. All right. All right, sorry, this class might have to run over time by a few minutes. What you're doing when you're grouping is basically, let's take a look, oops. Let's kind of split this polynomial into two sections. So one section is the x squared plus 3x, and one section is the 6x plus 18. So if we split into two sections, it's kind of easier to deal with because four terms is quite a lot to handle. So what we can do is let's take a look at the first section first. This was supposed to be an arrow. In this first section, is there any easy way that we can factor out a term where we can get two, I don't know, binomials or a monomial times a binomial? So we just want to look at whether or not we can take out a GCF. Well, in this case, yes, we can. We can actually take out the x from both. And if we do take out an x, we get x times x plus 3 on this side. Now on the right side, we can go through the same thing. Is there a greatest common factor between these two terms? Well, we have 6x and we have 18. So x won't work because x is only in one of them. But 6 is a factor of both because 18 is 3 times 6. So what we can do is we can actually take out a positive 6, which leaves an x plus 3. So now we're left with this value. But what we can, if we can remember this from our previous slide, it's not fully factored yet, but if we notice here, we actually have a common binomial factor of x plus 3. So we can actually take that out as well, which will leave us with x plus 6. Now it's in the form that we're familiar with, the binomial times the binomial. This same concept applies to B and C, but I don't want to keep you here too long, so I don't think I'll go over it. I will have all of these notes written up nicely, and I'll upload them to the drive. So the last thing that we're going to kind of look at is a summary. So today, what we've learned was, well, we haven't really learned about the difference of squares yet, so when we cross that out, the sum of squares, difference of cubes, we haven't looked at that yet. What did we do today? Yes, we looked at greatest common factor, and we looked at grouping, and a few more things that aren't on here. Distributive property. Oh my gosh, my writing is getting worse. Maybe I'll do it. Yeah, we kind of talked about distributive property. What else? Let's kind of scroll back up. Expanding and factoring. So yeah, next week we're going to continue with polynomials because polynomials is such an important unit. Pilot Prep decided to kind of split this unit into 2 lessons. Actually, I think three lessons. Yes, sorry, 3 lessons. So we're going to be looking at this for the next 2 weeks, I guess. So yeah, I hope you enjoyed this lesson. I will stop the recording now.